Okay, let's discuss what the graphs of polynomials look like. We've already talked about some of this stuff, so I'll probably go faster through some of it. But what you probably recognize or notice from the previous examples we've done in the previous sections is that polynomial functions are smooth and continuous. Okay, so when we're looking at these graphs right here, that is not a polynomial function. It's not smooth and continuous. This one, it's not continuous. Smooth, but it's not continuous, not a polynomial. The top two, the top and the bottom on the left, those are smooth and continuous. You can trace along it without having to pick up your pencil or give any sharp points. So that is the graph of polynomial functions. Okay, next, just like what we saw in the last section, we're going to talk about zeros of polynomials. Zeros of polynomials are just another way of saying x-intercepts. Okay, so there are some zeros that won't be x-intercepts, but we won't talk about that until they're like, well, you saw the one where we had a complex number. So we here have, for example number 2 here, we have f of x equals x to the 6th minus 3x to the 4th plus 2x squared. If I'm looking for the x-intercepts, and if you think about coordinates, the x-intercept has a y value of 0. So I'm going to make the y value 0, and we're going to try to factor it. Okay? All right. Make that a little bit bigger. Okay. So that's 0. And that might actually be too thick now. There we go. Equals. Okay. Now to factor, I'm noticing that all 3 of my terms here have an x squared in it. So if I take and factor out x squared, this will become x to the 4th minus 3x squared plus 2. Okay. Now, let's see. I do believe that this can be factored more. So we're going to keep factoring here. It's quadratic in nature. So I'm noticing that if I do an x squared term factor and another x squared factor, it'll probably work out for me. Now, let's see. I need to get it to be a positive 2 here. My only options are a 2 and a 1. Now, to get it to be a positive 2 on the back end, I need them both to be a positive or both to be a negative. I'm going to choose negative because I want it to equal, when I do my outers and my inners, I need that to simplify to negative 3x squared. So, all right. Next, I'm noticing that, well, at least the first one can get factored some more. X plus 1, x minus 1. The next one really can't. So because 2 it can't factor that nicely. Okay, it's not a difference of perfect squares. Now, I see that the degree is 6. And remember, if the degree is 6, that means that there is at most 6 zeros, or there is at most 6 x-intercepts. So I'm going to set each one of the factors equal to 0. You'll notice that this is actually 2 factors. So this one, x equals 0, there's another x equals 0 there. This one, x plus 1 equals 0. The next one, x minus 1 equals 0. The next one, I can't factor it anymore, so it's an x squared minus 2 equals 0. Now, when I'm listing all of my zeros here, or my x-intercepts, this was the first one I got. And I got it twice. The next one was an x plus 1 equals 0, subtract 1. The next one was an x minus 1 equals 0, add 1. The next one was x squared minus 2 equals 0, add 2. Square root. When you square root each side, you have to put in a plus, that is not going to work, a plus or minus. Okay, so this is 2, a positive root 2 and a negative root 2. Okay, I'm going to box all of our zeros here. There's another one, and there's 2. How many did we get? There's 6 of them. Here we have a multiplicity of 2 because that's a repeat, right? The root 2 ones, those are different numbers, right? As a decimal, it's like we have a positive approximate 1.4 and a negative 1.4. So as x-intercepts, we have 0, 0, negative 1, 0, 1, 0, root 2, 0, and a negative root 2, 0. There we go. All right, let's try it again. This one looks a little tricky. I'm going to refresh your memory on factoring. There's 4 terms here. It's unlike the previous one in that there was like, for the previous one, we could get this quadratic in nature piece. Here I cannot, but since there's 4 terms, I can try to factor by grouping. So let's do a little recall on factor by grouping. All right, so if I group the first 2 together, and I group the second 2 together, and I have to think about what I can factor out of each one of them. So when I look at the first 2, I see that they both have an x squared, which would, and if you factor that out front, you'd get an x minus 5. Picture yourself redistributing this, and you'll see that you get this. Okay, now I'm going to go to the second 2. Now, it's still a plus or a minus situation because I just did these 2, right? Now, it's either going to be a plus or a minus, and we have to decide which we want. I'm looking at these, and this one has a minus sign. So I'm going to factor out a minus sign, or negative 1, if you want to think of it that way. And if I factor that out, I will have an x minus 5. Now, I have students in the past say to me, why is it a minus sign? Okay, inside there when it was a plus above. Well, remember, you took out a negative so that you could have parentheses. If you picture yourself redistributing, you will see that you get a minus x and a plus 5. Okay. Now, the reason that we chose to do that is because I have 2 groups now. I have this whole group and this group. And both of those groups have an x minus 5 to factor out. Now, if I factor out x minus 5, what's left of this first chunk? X squared. Picture yourself taking this whole quantity and distributing it. That would take you back to what's underlined. Okay. Now, go to your second piece here. Picture yourself taking out x minus 5. The only thing left is that 1. Now, you have to put a 1 there because when you redistribute, this is what you should be getting, what's underlined. Okay? All right. So basically now I have that cubic function and I have it factored. So now if I'm trying to find the x-intercepts, remember that's what makes y 0. And I'm also noticing that this can get factored some more. X plus 1, x minus 1. It's a difference of perfect squares. Set each quantity equal to 0. X minus 5 equals 0. X plus 1 equals 0. X minus 1 equals 0. Add 5. Subtract 1. Add 1. Those are your zeros. As x-intercepts, they're the coordinate points 5, 0, negative 1, 0, and 1, 0. So if you were graphing this, you have a pointer, 5 zeros here. And positive leading coefficient up. The degree was 3, so it's going to end down. It's got to turn somewhere. And if you notice, and it was degree 3, that means 3 directions, and it means 2 turning points, right? That's at most. All right. Here it says find the y and x-intercept. So if I'm looking for the y-intercept, the x value is 0. If I'm looking for the x-intercept, the y value is 0. And it's nicely factored already. So first things first, let's just plug in 0 and see what we get for the y-intercept. So g of 0 is equal to 0 minus 2 squared, 2 times 0 plus 3. This will be a negative 2 squared, 3. This means that when 0 was plugged in, we got a 12. There's your y-intercept. X-intercept, we make the y value 0. Actually, since there's 2 of them, I'll just write them separate. Like so. And then set each one of them equal to 0. X equals positive 2, add 2. X equals positive 2, add 2. Here I'm going to subtract 3 and then divide by 2. So my x-intercepts are 2, 0, 2, 0, negative 3 halves 0. Next, find the x-intercepts of this one. Uh-oh. This one's a cubic function, but I'm not seeing too much for being able to solve it. Let's think about this for a second. We have a cubic. I don't think, if you want to pause the video and give this a thought, like could you do the grouping and would you get, essentially you'd be looking for like 2 x minus 6's. And I don't know if that's going to happen here with this one. So let's see. I think there is ways to do this, and it's going to come up in our upcoming sections. It's not by grouping. It's not by factoring. There is factors. However, you haven't been taught kind of ins and outs of doing that yet. It's definitely coming. So I think for this one, we just try to rely on a graph. Okay, so feel free to pause the video, grab your graphing calculator or a graphing device. I'm going to pause it also, grab my graphing calculator and show you what it looks like. So be right back. Okay, I did graph it and I'm going to take a screenshot here so I can drop it next to our document for us to communicate about. Okay, if it lets me, without messing up my font. Sometimes it messes up my stuff. All right. Kind of did. All right. Well, let's see. Okay, it says find the x-intercepts. So I think what I'll do is just come back to here. So since I'm looking for the x-intercepts, I'll walk you through the steps here. All right. So feel free to pause the video at any moment to write down the steps if you want to have like a cheat sheet of like how to navigate stuff with your calculator. Temporarily, of course, because once you're testing, you're not allowed to use cheat sheets and stuff, but it would help you just learn the ropes of your calculator. Okay, x-intercepts, we see that there are 1, 2, and 3 of them. Anything in blue, we're going to want to hit second first. So second, and then I'm going to hit that trace button because above the trace it says calc, which stands for calculate. And I'm actually looking for zeros. Zeros is just another fancy name for x-intercepts, or what makes the equation equal to 0. Now, if you have an 84, you're going to have to arrow to the left of one of your zeros. So I'm going to go after this one, and I'm going to hit enter. And then it wants us to go to the right of it. So I'm going to arrow over. And when I know I'm a right of it, I'm going to hit enter again. And then it wants us to guess. You can see that down here. I don't really care about guessing, so I often just hit enter again. It looks like we have a 0 at 1, the coordinate point 1, 0. So here, I'm going to say one of them was 1, 0. Now I knew I had 3, so let's go back and find the others. Okay, so that's that one, and I'm going to go second, calculate, and I'm going to go after another one. And this time I need to toggle an arrow all the way over if I'm going after this one. So there you go, that looks good. I'm to the left of that one, and now to the right of it. And you can guess if you want to. Looks like -2, 0. Okay, let's go again. Second, calculate, 0. And now I'm after this one. To the left of it, enter. To the right of it, enter. If you want to guess, go ahead. Otherwise, just hit enter. -3, 0. Those are the zeros of this function because it did something like that. Okay. Now, we mentioned earlier in a previous video that we have some multiplicity. Okay. Multiplicity, the number of times a 0 shows up, will indicate whether the graph touches or crosses the x-axis. So if that 0 happens, an even number of times, the graph is just going to touch or bounce off. Okay? Even multiplicity. If the graph crosses at that spot, we have odd multiplicity. Okay? And we should have the same number of zeros as we do degree of the function. But you have to count all the repeats. Okay? All right. So let's look at. Here I have a function graphed. I have an x-intercept here, here, and here. Okay? Now, I'm going to have to talk about that where it says 4 because that's going to be a little different. But I'll compare it to, say, graphing lines here in a minute. All right. So this right here, x equals -3, that is a 0. But that 0 happens an even number of times. And I know this because it touches the graph. It doesn't go through. So it's either twice, or 4 times, or 6 times, and so on. Okay? I stopped at 2 because it says that our degree is 6. All right? Next, I have it going through at -1. Now, when we graph, let's suppose you graphed the line y equals 2x plus 1. Here's your graph. That has an x-intercept right there, and it is nearly linear looking when it crosses it. Actually, more than nearly, that is a line, right? So if you look up at this one, is that looking like a line? Yes, it does look like a line. So that would indicate that it goes through, it's going to have odd multiplicity, and the straighter it crosses, the more line looking that it is, the least number of degree it has. So I'm going to say that's probably just degree 1. Okay, so that happens probably just once. Okay, but let's go over to the 4 now. I have x equals 4 as a multiplicity, but that doesn't cross it like a line. It crosses it like a curve. Now it can't be squared because if it was a degree 2, it would bounce off. So my guess would be that this is degree 3. Now, do I have 6 total? 1, 2, 3, 4, 5, 6. Yes. So identify the zeros of the function. Identify the function and their possible multiplicities. I think that's a typo. We could multiply it all out for the function or just write it as factored form. I think this is a typo and it should just be this. Okay. So my zeros are x equals negative 3 with multiplicity of 2. X equals negative 1 with multiplicity of 1. X equals 4 with multiplicity of 3. And these should add up to 6, the degree of the entire polynomial. And it does, so. All right. I'm going to pause this video here. We'll take a break and do another one.